Hello and welcome back to the lecture of time series econometrics. In this lecture, we're going to cover a very important topic called partial autocorrelation function. We have talked about partial autocorrelation function in the previous lecture. We have explained why we need partial autocorrelation function. And in this lecture, we're going to see how really the partial autocorrelation function or simply PACF works. Now, to understand PACF, we need to understand the difference between direct effect and indirect effect. Now, let us take a simple Ar1 model, right? The one here we have yt equal to phi yt minus 1 plus ed. Now, I actually get my present period value yt from my past period value yt minus 1. I simply use that number, the value, and I, you know, have a weight phi, and based on that, in my model, I get a value of yt. Now, that's an example of direct effect. But now, if I go to higher order lag, higher period lag here, and I express the same equation in terms of as a phi power h yt minus h plus a lot of error terms, right? Now, here what is happening is, of course, the influence of yt minus h on yt is declining, and I have a lot of error terms, but still I can express yt in terms of yt minus h, right? So that in the first case, what we have seen, this is called the direct effect. This is called the direct effect. And the second case is called indirect effect. All right, indirect effect. Now, the second case is actually a theoretical possibility. We can actually express yt in terms of yt minus h. But we can also, like, if we think how the yt minus h is actually influencing, if we look at this first equation, it has yt minus h in it. And how the influence is happening is the whole yt minus h term is actually influencing yt minus 1, and then this yt minus 1 is influencing yt. So that is why it is called indirect effect. Okay, all right. And the task that PACF is doing here is that PACF is actually cutting down indirect effect. PACF only considers if you have direct effect. Okay, so let me explain it further in terms of explaining PACF with corresponding mathematical notation. So PACF could be explained in two ways. One is by using conditional correlation coefficient, and second by regression. So when I say that I can express PACF with conditional correlation coefficient, so what I mean by that is, say I want to get, say, PACF between yt and say yt minus 3, okay, yt minus 3, and I will write covariance yt minus 3. Now I have to take into account the direct effect of yt minus 1 and yt minus 2, right? So that's my um, AR series where I have my yt minus 1 and yt minus 2 terms are coming before my yt minus 3, okay? Now in denominator we take the variance of, say, yt minus 3 given yt minus 1, yt minus 2, and another variance term is the variance of yt. Here also I have to take into account the effect of yt minus 1, yt minus 2, right? So that's how we express PACF. All right, and we normally, the notation that we use is, say, phi 3 3. Similarly, you can write PACF 4, PACF 5. Now the other way is to use regression. So this is my first way. So this is my first way where I use conditional correlation coefficient. Conditional correlation coefficient. And second method, we will be using regression, okay? So we know already how regression works. I don't need to elaborate a lot about regression. So for example, here my Ar1 model is nothing but a regression model, and I would be able to write something like alpha plus beta yt minus 1 plus epsilon, right? Or if I have a Ar2 model, I'll be able to write something like alpha, maybe alpha 1, beta 1, yt minus 1 plus beta 2, yt minus 2 plus epsilon t. Or if I am using, say, a 3 model, so it will be this, say, let me say 2 beta, say let's not write beta, let's say gamma 1 yt minus 1 gamma 2 yt minus 2 gamma 3 yt minus 3 and my epsilon term, okay, epsilon t. All right. So now if I want to get the PACF from all these equations, so what I can get, say, from this is again my equation 1, this is equation 2, and this is my equation 3. Now if I want to get the PACF, what I am going to get here is, say here, from the first equation, I can get PACF equal to PACF for yt minus 1, which is equal to beta. PACF for PACF for PACF 1 1 or phi 1 1, I can write here is beta. Okay. In the second equation, if I want to get phi 1 1, it is going to be beta 1. But if I want to get phi 2 2, then I'm going to have beta 2, right? In the third equation, if I want to get, say, let's say we want to get phi 3 3. Phi 3 3, I am getting gamma 3. I'm getting gamma 3. Or if I want to get phi 1 1, I get gamma 1, right? Or phi 2 2, I get gamma 2. All right. So essentially what is happening here is, when I'm actually trying to estimate the value of gamma phi 3 3 from equation 3, my regression equation is already taking into account my gamma 1 and gamma 2, the impact of yt minus 1 and yt minus 2. In case after taking into account the effect of gamma 1 and gamma 2, if there is something is left for gamma 3, so we'll find some value for gamma 3. So that's how we basically understand the concept of PACF. Now we need to understand there is a difference between when we express a higher order, say AR series, or a higher order MA series, vis-a-vis when we actually expand AR1 model or a MA1 model in terms of higher order lags. So there is a difference. So this difference is very important and we need to keep in mind. So one is to express a series in terms of its higher order lags, and other is you actually have a higher order series, right? So now keeping this in mind, we will actually derive the PACF for AR series and MA series. So let us write down PACF for AR series, Now what happens is, if I use a PACF for AR series where I have a, say, higher order ARP, so we'll have just what you have seen right now, an equation like this: beta 1 yt minus 1 beta 2, let's say we have order 2, yt minus 2 plus epsilon t. So what we will have is, we simply will get the coefficients for corresponding lag, right? So the PACF, if I have a PACF for phi 1 1 is going to be this, phi 2 2 is going to be this. So there is no problem here. Now if I actually think of expanding a AR series, AR1 series, in terms of, say, what we have seen previously, phi to the power h yt minus h plus all the error terms. So in this case, if I actually want to take a PACF, I will not have any PACF, no PACF value for yt minus h, and that is because this is an indirect effect, and the indirect effect is only to be mediated through yt minus 1, and which is already taken care of. So it has no effect. Okay. Now let us now think about PACF for MA series. So PACF for MA series, similarly we can think of two cases, PACF for MA series. So in the first case, you can have your MA series where you can expand your MA into many higher orders. So you can have, say, MA2 series, and then you have your epsilon t. So what will happen is, again, you will just simply run the regression, and in your regression you will get the values for the corresponding beta 1 and beta 2. But there is a trick here. It is not as simple as the AR case, and the trick is in MA series, and this is something you need to remember, in MA series, you always actually construct the series. You don't really have a, you know, you don't really, you actually get the error terms from the real observations. You really, nobody gives you the previous error terms just as it is. You have to compute that. So when you do that, you actually estimate the, say, ET minus 1. So if I have my ET minus 1 here, so I will be using this as, say, ET minus 1 equal to, say, oh, my YT minus 1 and something like this, right? So you actually estimate the past period error term from your model and from your actual. So now when we do that, so we automatically bring in the dimension of YT, right? And again, you will have another YT in this, another error term in this equation. I'm not writing it. And you will use that equation again, and you will have like more and more higher order YT values, right? So what happens in MA series, for example, if you look back our, remember our example of the ice cream seller, so you'll remember that that person was actually computing the past period error terms, and he has been doing it over a period of time, and all the past periods errors are being actually taken into account for when you're building the model. So that's what happens for MA series. You really do not have the basically the PACF actually would show PACF would show PACF will show impact or direct impact of higher order lags. So it is quite the opposite of what you have seen for AR series, okay? Higher order lags. Now, if I consider now, keeping this in mind, if I consider a higher order MA series, and if I actually express that higher order MA series in terms of higher order lags, so we will see it has a sort of influence of all the higher order, it will have lot of direct effects basically if we do that. Now, to conclude this lecture, let us finally summarize what you have found. So we can basically write down, say, I have a AR series, I have a MA series, I have something called ACF, I have something called PACF, and my ACF for AR series is going to be what? Like, it will gradually die down. It will not cut off, but whereas for MA series it will cut off, right? For lag 1 or lag 2 you have only values for those particular lags, whereas for AR series if it is PACF it will cut off, okay, and for MA series if it is PACF it will die down. So that's basically the understanding behind PACF.